Okay, everybody, today is Wednesday, April 4th. If you were absent yesterday, make sure you ask the sub for Tuesday's notes and homework, which there's a video on that. If you were absent Monday and Tuesday, ask the sub to get into Monday's folder and get the syllabus, the homework, and the notes. There's a video, 2 separate videos on the homework and notes for that. So 3 videos total if you missed Monday and Tuesday. Just 1 video if you missed yesterday. It's because I put the notes and homework together. So today, video number 4, Wednesday, April 4th. Solving exponential and log equations. This is what it's all about right here. This is what logarithms are so useful for in algebra and calculus, pre-calculus, CTM, the solving part. So now that we got all the little kinks out, now we're going to solve some equations. Okay? So today you're going to be solving exponential equations. That means you'll have like an x to the third, or you'll have something with the x in the exponent. There will be a variable in the exponent. And we're going to solve log equations. That means you're going to have the word log in an equation. So there's different kinds. So when x is the exponent and the bases are the same, you're allowed to cancel the bases. Okay, so if you only have one log in the problem, we swoop. That was last section. But now we might have something, we're going to be working with the same base. So you might be using that cardboard that's on the board. So you're going to cancel the same base if you have the same base. And then you need to rewrite in exponential form to get the same base. Okay? So in this problem, 9 and 3 are not the same base. But we practiced a couple days ago, like a week ago, actually 2 weeks ago because we had spring break last week, how to change a 9 to a 3. So look at the cardboard on the board. So we have this 3 to the 5x minus 3, right? That doesn't change. 3 is fine. The 9 is too big. So we're going to change 9 to 3 squared, because that's what 9 is, 3 squared. Once they have the same base, it says right here, cancel them if they're the same. We're going to cancel them if they are the same. Okay? So we're going to cancel them. Cancel, cancel. And you're going to set the exponents equal. You're going to add 3. Divide by 5, and x is 1. Okay, that's it. We already did these problems. We did these in our last quiz. Just a second. Hello. Okay, when x is the exponent, again, we can also do it. So in this problem, we could change it to the same base. In this problem, we cannot change 7 to a 3. You can look at the board up there. There's no 7 on the board. There's no 7 on the board. So we cannot change these to the same base. So I have some steps. So when x is the exponent, try to rewrite with a common base. That's what we did here. Okay, we did do that, and we were able to cancel and solve. If it's not possible, common log each side. That's what we're going to do right now. So you're going to write log on the left side, and you're going to write log on the right side. So you're putting the word log in front of the left side and the right side. So that's what step 2 is, common log each side. Now we're going to apply the power property to bring the exponent down. See this exponent right here? We're going to bring it down so it's in level form with everything else. So to bring it down, we're going to bring it out front, and it's going to blow up. In other words, it's going to expand. It's going to become a big X, big X. Log 3 equals log 7. Because that x is very important. That's what we're solving for, right? That's what we're solving for. So now, divide both sides by log 3 to solve for x. So now that the x is a factor out front, now I can divide both sides by log 3. This cancels, and x is about to be found by pressing log 7. Close that parenthesis. Divided by log 3. Close that parenthesis. And that's your answer, 1.7712. That's your answer. All right, example 3. So notice the x is up in the exponent. Can I change 4 and 3 to the same base? In other words, can I change 4 to base 3? No, I cannot. So that's step one. Try to rewrite with common base. I can't do it. So second step says, if not possible, common log each side. So we're going to common log the left side, and we're going to common log the right side. Now, this exponent is actually a binomial, so it's a little bit harder. We're going to take that whole exponent out front, but we're going to keep it in the parentheses because it's two terms. So make sure it's still grouped together so you don't lose part of it. That's all times log of 4 equals log of 3. To solve for x, I mean, I could distribute right here, but why? You don't need to. Let's get rid of log 4 by punching that in, and you have x plus 7 equals, and let's press in log 3 divided by log 4. So that's about 0.7925. We have this. We have this. I punch this in the calculator. We got this. So our last step to solve for x is to subtract 7. So we still have that on our calculator, right? So just subtract 7. Negative 6.2075. Now, just so you guys know, I shouldn't tell you this, but you can do these on the calculator. So left side is 4 to the x plus 7. Let's try it. 4 raised to the x plus 7. y2 is just 3. So let's press zoom 6 to make sure everyone's on the standard screen. So that's the 4 to the x plus 7. And here comes your y equals 3, if it ever comes. Where is it at? There it comes. Y equals 3. So then we just have to press seconds, trace, intersect, which is number 5. Press number 5. And see where it says first curve, we're going to press enter, enter, enter. Answer, negative 6.2075. That's the answer that we just found by solving. The first one we did, remember 3x equals 7? Let's try that one. 3 raised to the x, 7. This is my trick. That's how I teach my kids to survive the ACT test. Any equation can be done on a calculator. So that's 3 to the x. It's exponential. Here comes the horizontal line 7. See that they're intersecting? If you can't see the intersection, you have to expand your axis a little bit, but we can see it. So we press second, trace, number 5, intersect, enter, enter, enter. Answer is 1.77. Remember that? 1.7712. Same answer. So again, if you want to try this one on the calculator, you can, but that 10's kind of big, so you might have to expand your y max. I'm going to do this by hand. Can you write this with the same base? No, you cannot write e and 10 in the same base. So we can take the natural log of each side. Take the natural log. Whenever you are dealing with e's, you should always work with natural logs. Then you release 2x out front. And then you divide each side by natural log of e, which by the way is 1, but you might not know that because you're not familiar with this yet. So it's 2x equals, whoops, natural log of 10, natural log of 10, divided by natural log of e. It's 2.3026. And then you still have a 2 in front of x, so we're going to divide by 2. Divide by 2. And your answer is 1.1513. If we do this on our calculator, you would press in e to the x. Oh, it's e to the 2x. That's my fault. 2x. And then this one's 10. But you're going to notice that you can't see. This is what you're first going to see is e to the 2x. That's e to the 2x. Now the 10 is going to be way up here. You might not be able to see it. You can barely see it. So I'm not sure if the calculator will read this or not. Let's try. Second, trace. 5, enter, enter, enter. Oh, I guess it was good. 1.513, there it is. 1.513. So when there's a log on one side of the equation equal to a number, roll that log, aka swoop. We did this in the last notes. You may need to condense to have a single log equaling a number. This is a single log, so we're going to swoop. We're going to take that 4 and we're going to swoop over and pick up the 2. And that's going to be equal to x minus 2. So 4 squared is 16. We're solving for x, so add 2. X is 18. You're welcome to do that on the calculator if you want. It'll still give you 18. Although because this answer is so big, you would have to expand your x max to like 25 to get this. So let's just do it by hand. 6. So see how you have 2 logarithms here? That's not a good thing. It's kind of hard to swoop when you have 2 logs. So that's what this step right here is. Condense logs if necessary to get a single log. So it is necessary. We have to condense this to 1 logarithm. So the property from Monday says that if you're adding 2 factors, you're really going to multiply them. Okay, so let's go ahead and distribute x. Now we're going to swoop. So we condensed. And now we're going to swoop. So swoop, start with the 2. It's 2 to the first equals x squared minus x. Now bring the 2 over here. So it'd be x squared minus x minus 2 equals 0. Guess what? We get a factor. Yay. Factors of 2 that equal -1 or -2 and 1. So your answers are 2 and -1. Now you are not allowed to take a log of a negative number. So anytime you're solving these, I wouldn't say anytime, most of the time when you're solving these and you get a negative answer, it's not going to work. So because if you plug that -1 in right here, you can't take the log of a -1. So x equals 2 should be your only answer. You curious about what that looks like on the calculator? Let's look. Alpha window 5 2 x. There's the first one. Oops, that x doesn't go there. Delete. X goes here. Plus alpha window 5. There's your base again. Inside is x minus 1. That's the left side. And then the right side is just 1. So it looks like that. So you got the left side. And the right side is 1. And you press graph. Oops. Press graph. Remember, our answer was 2. It's showing that we have 2 answers here. But I said one of them doesn't work. Is this 1? So there's the first one. That's what the sum of those 2 logs looks like. And then here comes the y equals 1. And notice it only intersects 1 place, not twice. So you press second trace 5, enter, enter. It's not working. Let's try that again. Second trace 5, enter. Why is this not working? I think my calculator is going to die. Let me try the trace button here. You know why? I don't think the spider. Okay, I think you have to get the spider on there. My fault. Press trace and bring the spider up. Now try it. Second trace 5. You have to see the spider in order for it to work. There we go. Answer is 2. See right here in the left-hand corner is 2. All right, let's just do this by hand. So in this one, we're going to condense the logs. It says right here, if you have 2, condense. So we're condensing, and these are base 10, so they're easier when they're base 10. When you have a subtraction, you're really dividing. So you have x plus 2 divided by x equals 2. So you're dividing this by this. Now we're going to swoop. So we divide, condense by dividing. Now we're going to swoop. So the swoop is 10. That's the base. Pick up the exponent 2. Set it equal to all of this. Now 10 squared is really 100, right? I'm going to put that over 1, and I'm going to cross multiply. So this is 100x, because 10 squared is really 100. And then we're going to cross multiply 1 with x plus 2. And then subtract 2. Oh, wait a minute. Back up, back up. I have 100x and x. Let's subtract x to get 99x equals 2. And x is 2 over 99. Weird answer. But that's your answer. What is 2 divided by 99? 0.0202. So be my guess, put that in the calculator, but I'm not. This one we're going to condense, but first, before we can condense, what's wrong with it? What do you notice is wrong with this problem right here? See that 3? Where should I put the 3? Right there, because you can't condense with a number out front. So now that it's one, now they're both logs, we can condense this to one base, log base 5. So we are going to take x cubed divided by x squared. All this is equal to 2. Now, I would go ahead and swoop, but I'm not going to yet because I can simplify that. X cubed divided by x squared is just x. Now I'm swooping. 5 to the second equals x. So your answer is 25. And that's your answer. When there is one log, these are the easiest ones. The last two are the easiest ones. When there is one log on the left and one log on the right, you may cancel the logs. They must be the same base in order to do this. You may need to condense to have a single log on each side. See how there's a log on both sides here? This is the easiest ones. It's kind of like the exponent before. If you have the same exponent, just cancel. I mean, same base, just cancel. This is the same base. See that log base 4? Cancel them. They just drop the logs. I call it dropping the logs. Drop the logs. So we're just going to take the x plus 6 equal to 2x minus 5 and solve. So to get x on the same side, we'll subtract x. And to get x by itself, we're going to add 5. And x is 11. Make sure when you get these answers that you don't get a negative number. So if you take 11 plus 6 is 17. That's a positive number, so that's good. And over here, 22 times 11 is 22 minus 5 is 17. That's a good answer. On this one, we have 3 logs. 3 is a crowd. Okay, so we're going to make this one condensed logarithm on not the right side, just the left side. We're going to condense the left side. Condense left side. So we're going to write base 9 once. And we're going to divide x plus 6 and x because there's a subtraction sign. Now, do you see that you have a log base 9 on each side? So what we're going to do? We're going to drop the logs. Drop them. Get them out of there. So you're left with x plus 6 over x equals 2. Now, in order to solve this, you need to make both sides a fraction so that you can cross multiply. So starting with this, 1 times x plus 6 is x plus 6. 2 times x is 2x. Subtract x, and 6 equals x. Now, if you plug this 6 in, what's 6 plus 6? 12. That's a good log. Perfect. Plug a 6 in here, that's positive, so that's a good answer. So x is 6 is the answer. And let's go right to our notes or homework on U7G. Refer to example 2 to 4 on your notes. So here's examples 2 to 4. Refer to them. That's rewrite with a common base. If not possible, take a common log on each side. Okay? So is it possible to write these in the same base? No, it is not. So follow the steps. Rewrite with a common base. We can't. So it says if not possible, common log each side. So we're going to go log 3 to the x equals log 11. Now, use your property to release that x so that it is at the same level as the rest of the problem. Before it was too high and you couldn't do anything with it, but if you bring the x out front and make it a factor, now you can solve for this. So x times this. To get rid of log base 3, we're going to divide it because that's the inverse of multiplying. Wait, there's an 11 here somewhere. This is an 11. Sorry, guys. That's an 11. So you have a log 11 divided by log 3. Log 11 divided by log 3 is 2.1827. Can you get e and 5 in the same base? No, you cannot. Now, you can either log each side or natural log each side. Because there's an e, we're going to go natural log of e to the 6x equals natural log of 5. We're going to release 6x out front. And you need to know that natural log of e is just 1. Again, let's punch that in. Natural log of e is just 1. Whenever you see that, it basically kind of just goes away because it's a 1. So you really have 6x equals natural log of 5. And to solve for x, you would divide by 6. So x equals this, natural log of 5 divided by 6, which is 0.2682. 0.2682, yep. 0.2682. Can you put 9 and 5 in the same base? I can write 9 as 3 squared, but that doesn't, still not the same as 5. So we're going to take the log of each side. Bring the 2x out front. Now we're solving for x, keep that in mind. So we're going to divide first by log of 9. Punch that in the calculator. Log 5 divided by log 9. And you get this. Okay, so you have 2x equals all of this. Then you're going to divide that by 2. So on your calculator, just press divided by 2. And you get 3.3662. That's your answer. If you want to do these on the calculator, be my guest. It's the same answer. Can I get 8 and 12 in the same base? I don't think so. I think 8 can be 2 cubed, but 12 is nothing. So we're going to take the log of each side again. Hello? This is Mary. Hi. I'm actually just taking a fish oil pill, like vitamin, and a vitamin D, and 1 probiotic. Yes. And 1 silver Centrum for women over 50. That's it. Nope. I sleep with a diffuser at night. This has got like lavender and peppermint oils that come out of the diffuser. Nope. Nope. No. Nope. No. 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 Sometimes Band-Aids leave a mark, like a red mark on my arm. What'd you say? Giant Eagle Pharmacy in Pickerington. Yes. Yeah, I'm actually going in tomorrow to see the nurse practitioner. Yeah. Okay. Nope. All right. Thank you. Bye. sorry about that. Got a phone call. So this was a swoop. This has got a single log, so you're going to swoop. So 2 to the 4th equals x plus 5. 2 to the 4th is 16, and you're solving for x, so subtract 5 and you're done. This one is a little bit harder because it has 2 logarithms on the same side. So this is where you have to condense to 1. So we're going to condense to 1 log base 2. So you have 3x plus 5 divided by x equals 4. Now we're going to swoop. So starting with your base, you have 2 to the 4th equals 3x plus 5 over x. Put this over 1. Now 2 to the 4th is really 16, correct? So this is really 16 times x. So it's 16x equals 3x plus 5. And then you want to get all your x's on one side. And x is 5/13. Again, try that on the calculator if you don't like doing all that work. Put that on the left side, put that on the right side, and then 5/13 is a decimal. I'm not sure what it is, but you get the same answer. This one, we're going to condense to 1. So we're going to condense to a single. So we're going to go natural log of 4, and it's times x plus 2 because it's a plus. Plus means multiply, and the last one was a minus, so we divided. All this equals 3. Now, if you're going to swoop, you need to put an e in here. So this is e to the 3rd equals 4. I'm going to go ahead and distribute 4x plus 8. Might as well distribute that. Now, we're solving for x, so subtract 8. So you have e to the 3rd, e raised to the 3rd, minus 8 equals. So right now you have 12.0855 equals 4x. And then divide all that by 4, so just press divided by 4. And that answer is 3.0214. Number 8, bring that 2 out front because we can't condense if that 2 is out front. So make that an x squared instead of a 2 times that. Minus log x equals 3. I don't have any room here. Sorry, guys. Let me box this in. Okay, we're going to be right here. All right, so now that I brought the 2 up there, now I can condense. So this is log x squared divided by x equals 3. Now before I do anything, x squared divided by x is x. So you might as well simplify this to x. Now the base for log is 10. So now we're going to swoop. So it's 10 to the 3rd equals x. 10 to the 3rd is 1,000. And that's your answer. That's going to be a hard answer to get on the calculator because it's so big. So you might want to know how to do these. Now these two said refer to examples 9 and 10. That's these. Right? Where's 9 and 10? Sorry guys. 9 and 10. Follow the notes. You may cancel the logs, but first sometimes you have to condense to 1. We're going to be dropping the logs on this one. But I can't drop them yet because we have to condense first. Condense to 1. So you have log base 5 of x plus 3 times x. There's a plus sign, so we're multiplying. Equals log base 5 of 10. Once you get to a single logarithm both sides, you can drop the logs. Now I'm going to distribute my x. You get x squared plus 3x equals 10. Whenever you have an x squared in the problem, it means you have 2 answers, and everything must come to one side and set one side equal to 0. Because you will have to factor to figure out both your answers. Factors of negative 10 that equal 3 are 5 and negative 2. If you set those both equal to 0, you get negative 5 and 2. One of these probably doesn't work. It's probably the negative. So negative 5. If you put negative 5 right there, you cannot take the log of a negative number. So that is no good. It's called an extraneous root. So 2 is the only answer that works. Number 10, condense to 1, you get log. We're going to multiply 7 and x. So see how we condense this to 1? Once it's one logarithm, now you can drop. You can't drop them unless there's one on each side. You can't drop them if there's 3 of them. So 7x equals 37, divide by 7, and x is 37 sevenths, whatever that is. I'll just write it as 37 sevenths. Oh, I'm not doing all these. You guys are probably like, I'm not doing all these. Let's just do 2 of them. Which one does it look like we want to do? I think I want to do Let's do 12. In 2002, Russia had a population of 144,979,000. At that time, Russia's population was declining at a rate of 1.8% per year. If this continues, how long will it take Russia's population to reach 120,000? Use this and round to the nearest 10. So, this is our starting number. E, 0.018 T. They want to know when it's going to reach 120,000. This is a hard problem. Okay, so this is what you started with. They want to know when it's going to be this. So this is what logarithms are invented for. When you have to have a variable and exponent, how do you get rid of it? One way to do it is you can actually divide 144,000 to both sides. Get rid of the big numbers. So 120,000 divided by 144,979 is 0.82, we'll just call it 0.828 equals, so these are gone and this is gone. This right here is replaced by 0.828. Now we still have this e to the negative 0.018t, correct? This is what you do now. You cannot put e and 0.828 in the same base, so we're going to take the natural log of both sides. This is when you want to release this out front. Make this negative 0.018t natural log of e equals natural log of 0.828. Now natural log of e is just 1. So I just cross it out. Divide both sides by negative 0.018. So press in natural log of 0.828. That was what we got from the last one. Close your parenthesis. Divided by negative 0.018, which is the rate of decline. And it would take about 10 and a half years. Looks like about 10 and a half years. About 10 and a half years for the population of Russia to go from almost 144,000 down to 120,000. So their population is declining about 10 and a half years. Let's do Arizona or flu. Let's do the flu epidemic. Let's do one more, 14. So we have this formula right here, y equals YO E 0.075t. Number of victims of a flu epidemic is increasing at a rate of 7.5. That's this. They've already given that to you. If 20,000 persons are currently infected, find in how many days we can expect 45,000. So the starting number of people that had the flu was 20,000. That's how many people have reported so far to the doctors. That's how many doctor cases. It's a base that everyone can check at any time. So if it's increasing at 7.5% every week, how long we'll expect, how many days can we expect the total of flu people that have flu to be 45,000? This is called, like when they have outbreaks and stuff of measles back in the old days and polio and all that stuff. They could do this formula to figure out how many days. And they said, if we don't get the medicine within so many days, these people are going to die. And this is how many people we're going to be treating. This is how much we're going to need. And they did this by these kind of formulas. So we're going to divide by 20,000. Just so you know, these zeros all cancel. But I'll still do it on the calculator. You get 40,000 divided by 20,000, which is 2.25. So we have 2.25 equals E to 0.075t. So take the natural log of both sides. But we're going to release this 0.075t out front. Get rid of it. Natural log of E is 1. So you're going to divide both sides by the rate that it's growing. So you take the natural log of 2.25 divided by 0.075, 10.8 days. In 10.8, that's less than 2 weeks, 45,000 people will have reported to the doctor with the flu. And that's it.